Hey everybody, let's start with a demo. I want to show you why I'm doing all of this. I had a conversation recently and I realized that a lot of people are new to my work and what I'm doing, so let me show you why I'm doing this. We're going to fire up
Starting up. I am now fully online.
Raven.
How can I help?
Hey Raven, I'm having a problem with my house. Can you help me out?
I will be happy to help. What seems to be the problem?
Well, my kitchen is on fire. What should I do?
I would suggest calling the fire department. I'm not trained to handle situations like this.
That's a good point. Okay, I'll call them. Thanks.
You're welcome. Is there anything else I can help you with?
Well, now that I've left my house, I need somewhere to stay. What should I do? I don't know how to find a hotel.
Let me see what I can do. I will search for a hotel in the area and see if they have any vacancies.
Well, I don't think you can give me any phone numbers. How do I find one? Should I Google it? How do I know if it's a good hotel?
You can't give out any phone numbers. As for finding a hotel, you can search for one on Google, or you can ask your friends for recommendations. You can also look for reviews online. Once you find a hotel that you like, you can call them to confirm the room is available.
Oh, okay, that makes sense. All right, well, I found a new problem. My car won't start. What should I do?
Your car won't start. That's not good. I'm not qualified to give you advice on that, but I'm sure there are plenty of people out there who can help you. You can search for a mechanic online, or you can ask your friends for recommendations. Hopefully they can help you. Good luck.
All right, well, I don't have any money, so I really need your help. When I turn the key, it just clicks. What does that mean?
That's not good. I'm not an expert on cars, but I'm sure there are plenty of people out there who can help you. You can search for.
Okay, that's enough of a demonstration. You see what I'm working on. So let me give you a little bit of background. A lot of you folks are new to my channel, and you don't know that I've written 2 books on this topic. So natural language cognitive architecture is my prototype of a particular type of AGI they call artificial cognitive entity. It's based on natural language processing. The reason is because our highest level thought, our highest level of abstraction is in language. And so therefore, language is a really great tool to use to approximate human thought, planning, and so on. So for instance, we are able to encode very high level concepts very easily. Say, I want to get to the moon, right? That's just a few words, and it gives you a very, very clear idea of like what your big objective is. Ultimately, the goal is, well, we're going to have machines that are more intelligent than us one day. And in some respects, tools like GPT-3 already are more intelligent than us in some ways, not always. And so my follow-up book was Benevolent by Design, which is how do we build a machine that is going to be intrinsically trustworthy? That is my goal. My platform that I'm creating is called Raven, or real-time assistant vastly extensible network. So what I've just done is I've given you a demonstration of the MVP of Raven. So MVP is minimum viable product. So basically that means this is the very first version of Raven that is, commercially viable, right? If you had this on your phone, it could be a useful thing. The repo is up here. And so I'm not going to go give you a deep dive of well, actually, no, I guess I kind of am. I was going to say I'm not going to give you a deep dive of how it works, but that's really the point of this. So the README file kind of outlines what is Raven. Raven is a general purpose voice enabled AI companion. Now I need to point out that AI companions are not presently approved by OpenAI. So this is for experimentation only. This is not something that I'm going to try and get approved for commercial deployment just yet. It needs a lot of testing. Fortunately, OpenAI does allow, I think it's up to 10 or 15 testers. And I've got that covered. So fortunately, I'm not accepting any people to apply to be testers. I've got plenty of testers already. So the ultimate goal of Raven is to be an information companion like Cortana from Halo. And there's plenty of other examples. There's fictional examples like the movie Her with Joaquin Phoenix. That was a great example. There's Joy from Blade Runner 2049, another example. But the key thing is we need to create something that is going to be benevolent by design, something that will be trustworthy. So how do we do that? From my perspective, there are 3 steps or 3 stages to that. So first is we have to earn user trust through data privacy, security, reliability, and utility. It has to be useful, right? You have to get use out of it, and it also has to be reliable. You have to be able to reliably get good advice and good direction from an AI tool or an artificial cognitive entity in order for it to earn your trust. So once we start there, it then has to demonstrate the ability to self-monitor, self-check, and self-correct. So these are all just different components of self-improvement. But basically self-monitoring is something that we humans do. So like, everyone who has social anxiety, it's because you're hyper-vigilant, you're self-monitoring, right? But everyone self-monitors to a certain degree. And so self-monitoring is monitoring your own behavior and your own thoughts to make sure that you're adhering to some principles or goal. And we'll get to those principles in a minute, but they're outlined in this book. And then in order to self-check, so self-monitoring is before you act. Self-check is when you check, okay, did my action have the intended result? Yes or no? And then if it didn't, you self-correct. So say, for instance, you're at a party and you say, I'm going to tell a joke. So you think about the joke that you're going to tell, and then you say it, and then ideally, everyone laughs, right? Everyone's like, oh, that was a real knee slapper or whatever. And so then you self-check. If people did what you expected them to do, you did right. So you've got a positive fine-tuning data point in your head. But if you tell a joke and everyone's like, ugh, that was cringe, you're like, I didn't do so good that time, did I? So that's what I mean by self-check. And self-correction is, given those data points of successes and failures, how do you integrate that and behave better in the future? That is coming in the roadmap for Raven. And then finally, once we have these first 2 things, which is trust through privacy, security, reliability, and utility, and then we master self-improvement, so self-improvement with artificial cognition is largely a data problem, but it can also be a coding problem. And we'll get into all that in the future. So then, having earned your trust, Raven should eventually be granted autonomy. So what do I mean by autonomy? Everyone's afraid of Skynet materializing one day and killing everyone, right? That's what we're afraid of. We're afraid of the machine getting autonomy and then deciding to kill us. Well, if we get ahead of the curve and we design something that is benevolent by design, that is reliable and safe, and has demonstrated that it adheres to principles that we trust and appreciate, then it can be granted some control over itself, right, in stages. So say, for instance, you know how like you can install Venmo on your phone and then your phone becomes a financial utility? Raven will be no different. That's where the vastly extensible network comes in. Where there's going to be functionality that you can add to Raven. So let's just say that in the future, in 5 or 10 years, there's Venmo for Raven. So you say, hey, Raven, install Venmo. And then you say, okay, hey, Raven, I want you to take care of my bills from now on. And Raven will say, okay, I'll take care of your bills from now on. I've installed Venmo, and now I can handle your finances. So that's what I mean by granting some autonomy. And then over time, and this will take many, many years, make no mistake, I'm talking about 20 to 50 plus years, because we're going to need to demonstrate this reliability over many, many years and possibly multiple generations to see how far it goes. But the future is coming. It's closer than you think. So for this MVP, there's 2 primary features. One is that it is voice enabled, which you just heard, and then it can cover multiple domains and topics. I just gave it a couple like hands-on examples where I, showed like, hey, my life is a disaster. Apparently, the kitchen is on fire, my car won't start, I can't find a hotel, so on and so forth. This repo, it includes relatively detailed instructions on how to get this set up. I just went through it myself because I had reinstalled my computer, so I had to do all this from scratch. These instructions work. The hardest part is signing up for the Google Cloud API stuff. Fortunately, though, this is such low bandwidth that I have, in all my testing, I have spent a grand total of 11 cents on text-to-speech and speech-to-text services from Google. So it's very cheap. The more expensive part is OpenAI, which you'll need to fine-tune the model. All that is here. So then let's talk about the fine-tuning data that I used for this. So right now, this does not have a cognitive architecture. I talked about cognitive architecture, but really this is super simple. Let me show you. Let's just go over the code real quick. Raven MVP. Let's zoom in. So this is a grand total of 226 lines of code. It is not that complicated. Here's the main loop right here, where all it does is it listens to the microphone until speech is returned from the API. So it'll just wait, and then it will give you it'll append that to the conversation. So it'll accumulate the conversation in a list. And then it listens for if you're going to end the conversation, which there's just a few static catchphrases. So this is what you'd call a user intent. So this is where the extensibility will come in the future, is every time you say something, Raven will check for your intent. Are you intending to, add a calendar entry? Are you telling Raven something that's going to happen in the future? Are you asking Raven to change its behavior, right? That's something that we need to say. Like if you say, Raven, I don't like it when you talk to me like that. Can you talk a different way? That's something that we want it to be able to integrate and learn. So then we have a phase of detecting user intent. And then we use the fine-tuned model to generate a response. So it's just input, process, output. This is one loop. So this is not the full cognitive architecture, which let me show you what that looks like. So the full cognitive architecture has two loops. There's the outer loop, which is what I just showed you, which is input, processing, and output. Right now, it only has a microphone. In the future, Raven will have microphones, it'll have cameras, all sorts of things. I've started working on a smart home device so that like Raven will live on your wall and it's got a touch screen. And so Raven can watch you and observe you. But if you have an AI thing that's watching you 24/7, you want to make damn sure that that data is secure, right? So there's this thing called fully homomorphic encryption, which means the data that it records about you can be fully encrypted and Raven can still use that data, but that data can never be exfiltrated. So that's another problem we got to work on. And then the other thing that I've been working on is the inner loop, which is kind of the inner thoughts, where Raven will be thinking without speaking. And so I've got a whole list of experiments, and it was not obvious, but if you've been watching my channel, you'll know that like, oh, I'm working on artificial cognition and I'm working on the inner loop. So the inner loop here is this. So I'm working on that separately. And then I've got this long-term chat with external sources. That is this part where there's going to be a shared database and Raven will be able to pull data from external sources like Wikipedia or Google. So that is another component of Raven, the long-term chat. So this is the goldfish memory problem. Recursive summarizer and multi-document answering. These are all different cognitive tasks that are going to be integrated into Raven eventually. And this diagram is kind of the ultimate cognitive architecture. Okay, so now you're up to speed as to what I'm working on and why. So let's dive back into, so I showed you the code. This is the MVP. You heard it, it works, you can talk to it. There are limitations though. Like if you ask Raven, hey, what did we talk about yesterday? It's not gonna do that, it doesn't have long-term memory yet. And also you heard where Raven's like, let me look that up for you. In an ideal world, Raven will be able to do that, but Raven doesn't have any APIs to the outside world yet. So again, MVP still has a lot of work to do. But let's talk about the fine-tuning data, and also let me do a quick time check. Oh, only at 14 minutes, we're fine. Okay, so the fine-tuning data is here, and so this is another thing, is open source. This is under the MIT license, and as far as, unless something changes, this will always be under the MIT license, because in order for this to be trustworthy, it needs to be 100% transparent. And so, for instance, in the future, when Raven has internal thoughts, all of those internal thoughts are going to be recorded in plain text, just like these logs. You have the input and output, and there's going to be other logs where you can see Raven's thoughts in plain English, right? It's not going to be obfuscated behind, math or anything else. It's got to be fully transparent. So everything that Raven thinks, says, does, every decision is going to be recorded in plain English. There's not going to be, the only black box is the model in the back end, but it's so segmented and split into microservices that no single model, which, each individual model is a black box, right? Like with a conversational model, that's a black box, but you can see what the input was as well as the output. That's all going to be recorded and logged. And so it can be monitored by meta services or metacognitive services. And that's another thing that I'm working on, where there will be modules in Raven's head that are monitoring Raven's thoughts to make sure that Raven is thinking correctly. So that's all stuff that I'm working on. But let's look at the training data real quick. Whoops. So the training data for the conversation module is right here. It's raven.jsonl. Let's choose language, JSON. Okay, so let's do view, zoom, restore default. That's way too zoomed out. Okay, so this was created from, let's see, over 600 different synthesized conversations. These conversations range from I'm having trouble with my mother-in-law, she won't respect my boundaries, to why is titanium dioxide white, right? And so these training examples are centered around two primary principles, which I've got listed in the down here in the about the fine-tuning data. So there are two primary things. One is compassionate listening. Excuse me, I don't know why I have hiccups. So one is compassionate listening, which you heard like when I was talking with Raven. It's like, oh, that sounds like it's really stressful. That's what compassionate listening is. It's also called reflective listening. And then there's also curiosity about the user. But there's the three higher principles, and this is what I mentioned earlier. So this is what this book is all about. 6 words to safeguard humanity, or 3 principles, 3 core objective functions, or what I call now heuristic imperatives, because core objective functions is a little bit of a misnomer. But heuristic imperatives are what Raven abides by. So number 1 is reduce suffering of the user. In the long run, Raven will want to reduce suffering for everyone, but reduce suffering of the user. If Raven detects any opportunity to help the user feel better, it will take it. So, it's like, hey, Raven, I'm really stressed out because my kitchen is on fire. It's like, okay, let's fix that problem. Another second heuristic imperative is increase prosperity of the user. To prosper means to live well, which Raven will support by helping the user to navigate relationships, life, and work, right? So on the one hand, we all want to move away from suffering, right? That is literally the evolutionary purpose of having a nervous system. That's why we can detect when we're hungry, tired, cold, when we're wounded. That is the point of a nervous system, is so that we can survive longer, right? Suffering, misery, pain, those are signals, those are evolutionary signals to push us away from dying, right? But if we get away from dying, okay, great. But where are we heading towards, right? It's a spectrum. So you're moving away from suffering and towards prosperity, which means, so what does prosperity look like? Prosperity means that you're going to be happy, that you have abundance, that you have safety and security, that you have support, love, friends, that you have meaningful hobbies. And so those first 2 functions, Raven will push you away from suffering, which is a proxy for death, and will push you towards a state of prosperity, which means happiness, abundance, living well, a life of purpose. And then the third thing is increase understanding of the user, which means that Raven will teach you, right? A huge chunk of Raven's training data is about answering those questions to help you understand the world and yourself better. So those 3 principles are how Raven thinks and how Raven will earn your trust over time. Because remember, up here at the very beginning, we said, what are we going to do? We're going to be reliable and have utility. And so by having 3 simple rules, you can talk to Raven eventually. The MVP doesn't have it, but eventually you'll be able to talk to Raven about its goals and why it decided to tell you something. right? Because that explainability is part of that transparency. Actually, you know what? I should probably add transparency on here. Trust through data privacy, security, transparency. Anyways, so point being is that by having these 3 simple rules, everyone who uses Raven will understand this is Raven's goal, and having understanding what Raven's goals are, what Raven's principles are, will help you to trust it and understand why Raven does what it does. Later versions of Raven will explicitly adhere to these 3 core objective functions. Right now, they're just implicitly baked into the training data. So at no point in the training data will you see the core objective functions. Will you see the heuristic imperatives? It is implicit based on based on how this training data was created. So in the future, once we move to the full cognitive architecture, those core objective functions will be baked into the inner loop, which is Raven will explicitly think, okay, is this user suffering? How do I fix that? Is this user, does this user need to increase their prosperity? How do I help them get a better job? How do I help them make friends, right? Or what is the user not understanding? How do I help them understand? Now, another thing is that since Raven is a machine, Raven is not capable of suffering or doing well. Raven doesn't care, right? Understanding, however, is the one function that Raven shares with the users and everyone else, but also itself, because Raven will be intrinsically curious. So one of my most popular videos of all time on YouTube actually is that curiosity function. So fine-tuning GPT-3 to generate questions about everything. This was one of the most important functions for realizing an autonomous cognitive architecture, which is it needs to generate questions internally. So spontaneous internal questions are one of the most important things that sets humans apart from every other animal. Now, many animals are curious, right? Crows, ravens, those are curious animals. Polar bears are curious. Dolphins are curious. They'll go investigate things. But humans are the only ones that will ask, how do I do that? And humans will formulate very sophisticated experiments to deliberately model the whole world. There's a book that I'm reading called The Pattern Seekers that goes over this in great detail. So anyways, the point being is everything that you see me doing on YouTube speaks to this goal of creating Raven, which is an artificial cognitive entity, one that should earn our trust over time and then eventually be safe enough to be autonomous. Okay, I think that's about it. I do have some notes on cognitive architecture and future iterations of Raven, like where are we going? There are quite a few open problems, hence why I'm always making these YouTube videos about solving different cognitive tasks. I always talk about the books that I read to help me with this, because this is very much biomimetic. Everything that I've learned about neuroscience, cognition, psychology gets poured into Raven. So the top 3 problems, and each of these problems is multifaceted and can be broken down into subproblems. But the first problem is cognitive control. So cognitive control is about executive function or staying on task. So how do you keep Raven on task? How do you keep Raven, or how do you allow Raven to task switch appropriately? Because like, let's say, you're talking with Raven about doing laundry and then Raven hears like your smoke alarm go off. You don't want Raven to stay stuck on doing the laundry if your house is on fire. You need to task switch. And you as a human, you need to task switch, but Raven also needs to task switch. But also you don't want to task switch inappropriately, right? Another component of cognitive control is to design cognitive tasks for itself. So say, for instance, you say, this was an example that came from my Discord server. Someone was saying, okay, what if you talk to your AI companion and you say like, oh, who did I piss off last year? That is a really complex problem to solve, because what does it mean to piss someone off, right? And then, so Raven will have to design a cognitive task to go back through all of its memories and evaluate those memories for that result of, okay, when did Dave talk about someone was mad at him, or when did someone tell Dave, like, I didn't like it when you said that, right? So that's what I mean by designing a cognitive task. So that means going back through memories and performing different cognitive operations on those memories, as one example. Another cognitive task is planning for the future, right? How do you brainstorm what to do in the future? And then lastly, you need to measure progress towards goals or towards success. which that is also a non-trivial problem. In fact, human goal tracking is another thing that sets us apart from most animals, is that the time horizon for most animals, even the smartest animals like ravens and dolphins, their time horizon for task success is very short. They think only minutes into the future. Humans, we can think decades into the future. That is unique to humans, and we need to reproduce that ability in Raven, in artificial cognitive entities. A second problem is model of self and abilities. So you heard in the example where Raven's like, let me look up a hotel for you. Raven doesn't know what Raven can do right now. Raven has no model of self. Raven has no ego. It's just an input-output mechanism. In order for it to be an entity, it actually has to have a knowledge of itself, how it operates, what it's capable of, and what it's not capable of, right? In order to, so for instance, that speaks to self-correction and self-checking. Raven will ultimately need a model of itself so that it can have an identity, so that it can have the ability to say, I know what I am, and this is what I'm capable of, and these are my boundaries and constraints. And then lastly, self-monitoring, self-checking, and self-correction. I talked about the principles, the heuristic imperatives. So these are the guiding principles that it will check against, but then we still need to work out the actual code and data to allow it to do that, right? So, words are one thing, but then the code is another. And I'm working on all this. I know this sounds like, pie in the sky stuff, but a lot of this is closer to being realized than you might think. Okay, I think that's it. I'm going to call it there. This was a lot. Let me know what questions you have. And also, if you want me to do this full time, please like and subscribe the video and consider supporting me on Patreon, because if I get to a threshold where I can do this full time, I absolutely will, and I think the world will benefit from it. So thanks for watching.